Okay, so in this third session, we are going to learn about how to assign dead load and live load in this model. Okay, so now we are going to learn how to assign dead load and live load as per ASCE 705 or BNBC 2020. We will assign dead load and live load here. Okay, so to assign our dead load and live load, first of all, we have to go to our load and definition. Okay, first of all, we will go to definition. First of all, we will assign seismic definition. Just go to here. Okay, just for the time being, keep just ASCE 705 and just add. Okay, nothing, just close, nothing. Okay, and then we will go to load case details. Okay, click here and then add. Okay, so first number. Okay, then this load we'll have to assign seismic load first, then dead load. Okay, then dead load, live load, and then our wind load. Okay, so first load is seismic load. Okay, so this load is EQX. Okay, yes, I want to save it. Okay, so EQX. Okay, along positive direction. Okay, add. Second one is EQX, negative direction, add. Third one is EQZ, positive direction, just keep a copy, add. And the fourth one is minus Z direction. Okay, add. Okay, then we will assign dead load. So and then we will go to dead load, simply DL. Okay, then we can go to roof live load, which is LR. Okay, then we can go to floor live load, normally live. Okay, then LF. Though we don't have any floor loading, but we will keep that in our load case. Okay, no problem. Okay, add here. Okay, let's make it live load floor, add. Okay, just close it and we just make it live load roof. Okay, and then change. Okay, so we have assigned the load case. First of all, for load case of earthquake, then dead load, roof live load, and then floor live load. And in next classes, we will assign our wind load cases. Okay. So now we can now we need to see the calculation of how we can calculate the dead load. Okay. To calculate the dead load, I have a calculation here. Here you can see. Here. Dead load are coming from self weight. This is the self weight of the structure. Dead load is coming from roof sheet. You have a sheet above, and load from purlin. So self weight plus roof sheet and purlin. Okay. So total dead load is coming from these three items. Okay. So self weight of the structure is model will automatically calculate it. So to do that, what we have to do, just go dead load here, add here. Okay. If we go to self weight, okay, -1, okay, just add it, okay, and then close it. Okay. Then select this one and assign to view. We need to assign to all the model, whether it is steel part, RCC part, we have to assign this to all the parts of our model. So assign to view and then assign. Okay. So self weight is automatically assigned. Okay. Now, if we go to the calculation, if we see, you can see it here. Roof sheet thickness 0.50 mm. So load from profile sheet or roof sheet is 4.5 kg per meter square. So load on rafter due to roof sheet, this is done to, convert kg per meter square to kilonewton per meter square. Okay. And spacing of rafter. So here we got the value of load from roof sheet. And self weight of the purlin, this is the width of the purlin, and this is the thickness of the purlin, and this is the unit weight of the steel. So what is the value? 5.65 kg per meter. Then again, it is converted from kg per meter, to kilonewton per meter, and spacing of the rafter and divided by spacing of the purlin. So the value is 0.27. So the total dead load on mid frame, a load from purlin and load from sheeting. So 0.54. But at the end frame, it will be divided by 2. Okay. So these are the value 0.54 and 0.27. Okay. Now, we can go to our model. Okay, we can go to our model. Click on here, then add. Yes, we want to save it now. Okay, and add. You can see there is a member. Okay, uniform force. So what was the value? Minus 0.54. Okay, downward. That's why negative. Global y-axis. Okay, then add it. At the end bay, it was 0.27. Okay, then add it. Okay. Okay. Then we will have to assign this value. Then click on here. Then we have to select. We can select easily. Go to select. Okay. Go to select and select 1, 2, 3. These are all our mid frame. Okay. So these are selected. Then just here you have to assign to selected beams. Okay. Then assign it. Already assign it. Then click here, 0.27 value. Then select. Okay. Then go to your last property 6, and then assign to selected beam. Okay. So this values has been assigned to the frame. Okay. Now, but we have to look here. There is another loading here, dead load. Okay. So in this calculation, if you go there, if you see there, in this calculation, there is no collateral load is considered. But in case your model, there may be a collateral load. Collateral load may be coming from false ceiling, solar panel, or any other external loading, excluding your self-weight, purlin, and roof sheeting. Okay, so it will depend upon your structure. Okay, so another dead loading is there, that is dead load on grade beam. Okay, dead load on grade beam. If you see the section, here, our section, you can see there is a 25 mm brick wall, here. Okay, the total height of the brick wall is 5,975. So this load will actually go to grade beam, and from grade beam it will go to the RCC column. Okay. So now what is the value? Load on grade beam from 25 mm wall. This is the calculation. It is 28.17 kilonewton per meter. Okay. Then go again, dead load, assign. Again, what is the value? Minus 28.17. This is downward, then add it. Okay. And then select it, and then go to here, select. Okay. And then this is our grade beam, and just simply assign this value to all the grade beams. Okay. Now this value has been assigned here. Okay. So dead load has been assigned. Okay, so dead load has been assigned. Okay, assigned like this way. Now we are going to assign live load on roof. We don't have any live load on floor because there is no floor. Okay, so we have only live load on roof. Okay, so then click on here, add, okay. Go to the member load down, GY global y-axis, and then we can see our calculation. Here is our calculation, roof live load calculation, live load on rafter mid frame. Okay, what is the value as per ASCE, as per ASCE code, as per ASCE code oblique BNBC 2020, you know, the roof having sloped, okay, there will be a live load of 1 kilonewton per meter square. It may change upon your code, you know, your country code, but the calculation will be same. All the calculation will be same. Only this value may change upon on your code. Okay. So as per ASCE code, this is 1 kilonewton, then 1 into spacing of rafter. Here we can see the spacing of rafter was 6.1 meter. So 6.1 meter at the mid frame, and then end frame, just half of that value, that is 3.05. Okay. So we going to here, and that value is minus 6.1. Okay. Then add it, and then minus 3.05. Then we just add it. Okay. Okay. Yes, I want to select it. Yes. Yes. Okay. Select it. Select. Okay. Then go to property name. Here is 3, 4, 5. Okay. So this is just assign here. Okay. And select, go to this value, this property, sorry, assign this one with this value. Then you can see our roof live load has been assigned to our frame. Okay. Live load, and here you can see 0.5 for loading, and then this one and this one, if roof live load this one, and for this one. So this is the way to assign dead load and live load on the structure. Okay, on this structure. I hope you like it. Okay, so please do subscribe if you like it. Thank you. We will see you in next session. Okay, thank you.